Assalamu alaikum wa rahmatullah. Today, inshallah, we're going to solve Cambridge exam October-November 2024, paper 43. Let's start it. Question 1. A list of substances is shown. Answer the following questions using this list. Any substance can be used once, more than once, or not used at all. First one, it is manufactured by fermentation. We have ethanol that can be manufactured by fermentation of glucose using yeast enzymes. So the answer here is ethanol. Second, it is monoatomic. Noble gases or group 0 elements are monoatomic. They exist as single atoms. Here we have helium, one of the noble gases. It is monoatomic. It is a reactant in photosynthesis. In photosynthesis, plants use carbon dioxide and water to produce oxygen and glucose. So carbon dioxide is the reactant in photosynthesis. It is a solvent used in the extraction of aluminium. We use cryolite to dissolve aluminium oxide and to decrease the melting point of aluminium oxide. So the solvent is cryolite. It is an ore of iron. The ore of iron is hematite, which is mainly iron 3 oxide. It is manufactured from methane. Hydrogen can be manufactured from the reaction of methane with steam. So hydrogen gas is the answer. Hydrogen can be produced from the reaction of methane with steam. Which substance is a compound with a giant covalent structure? We have in the list here silicon 4 oxide, which is a giant covalent structure, has a structure similar to diamond. So the answer is silicon 4 oxide, used as lubricant. It is graphite. And the last one, it is tested with lime water. Lime water is used to test the presence of carbon dioxide gas. So the answer here will be carbon dioxide, where carbon dioxide react with the lime water, which is calcium hydroxide, to produce the white insoluble solid calcium carbonate, and that's why the lime water turns cloudy or milky. Question 2. This question is about electrolysis. State the meaning of the term electrolysis. Electrolysis is the breakdown of ionic compound which is either molten or aqueous by the use of electricity. Here the table gives some information about the electrolysis of two electrolytes using graphite electrodes. The first one, concentrated aqueous potassium iodide. When the solution is concentrated, here we have potassium ion, iodide ions, and protons, OH ions, also from water. But when the solution is concentrated, iodide ion is attracted to the anode and discharged as iodine instead of the hydroxide ions. So here at the anode, we will have iodine, and of course iodine is a brown solution. And at the cathode, we have bubbles of hydrogen gas produced. Bubbles of colorless gas will be hydrogen, because potassium will never discharge at the cathode as it is one of the highly reactive metals. The second electrolyte, aqueous copper sulfate, we have copper ions and sulfate ions, H and OH ions from water. At the cathode, copper ions attracted to the cathode instead of hydrogen ions. So the product at the cathode will be copper metal, which is pink brown solid, because copper ions accept protons at the cathode to form copper metal. And at the anode, sulfate ions never discharge, and instead OH ions will be attracted to the anode to produce oxygen gas. Again, we have bubbles of colorless gas, which is oxygen. So the question is asking about complete the table, and then oxygen is produced at the anode when we make electrolysis for the aqueous copper 2 sulfate. Write the ionic half equation. OH ions is attracted to the anode. We have 4 OH ions losing 4 electrons to form oxygen and 2 molecules of water. This is the half ionic equation for the reaction at the anode. Aqueous copper 2 sulfate is electrolyzed using copper electrodes instead of graphite electrodes. Explain why the mass of the anode decreases during electrolysis. When we replace the graphite electrodes with with copper electrodes, copper ions from the electrolyte attracted to the cathode, where it gain electron and form copper metal deposit on the cathode, and the copper of the anode ionizes to replace the electrolyte. That's why the anode decrease in mass. So the cause of the decrease in mass is the anode ionized to produce copper ions, which goes into solution to replace the electrolyte. Name the product formed at the cathode. As we've just said, it is copper metal. State what change, if any, is observed in the appearance of the aqueous copper sulfate. There is no change will appear on the aqueous copper sulfate. The electrolyte will remain with the same color and the same concentration because copper ions removed from solution to form copper metal on the cathode are replaced by ionization of the anode by the same rate. So there will be no change in the color of the solution of copper sulfate or the concentration of copper sulfate. This question is about compounds of tin. Tin 4 oxide has the formula of SnO2. The relative formula mass of tin is 151. Calculate the percentage by mass tin in tin 4 oxide. So we have the MR for tin oxide, which is 151. Then we will have to know the relative atomic mass for tin, which is 119. So 119 divide the total mass will be 119 divide 151 times 100. This will be the percentage by mass 10 in tin 4 oxides, 78.8%. Tin 4 oxide is amphoteric oxide. That means it can neutralize both acid and alkali. Tin 4 oxide reacts with aqueous sodium hydroxide to form sodium salt and water only. The sodium salt contains the negative ion with the formula SnO3 minus 2. State the meaning of the term amphoteric. Amphoteric oxides, substance that can neutralize or react with both acids and bases to produce salt and water. The simple equation for the reaction between tin 4 oxide and sodium hydroxide to form salt containing this ion and water. So we will write first the tin 4 oxides and sodium hydroxide, and then the formula of this ion. This is the negative part of the salt that will be formed, and the positive part, of course, will be sodium because it has a -2 charge and sodium has only one positive charge. So we will have to use 2 sodium ions, and this will be the formula of the salt, Na2SnO3 plus water. Then we have to balance the equation by adding 2 in front of sodium hydroxide. Tin is a metal that forms both covalent and ionic compounds. Suggest why this is unusual for a metal, because covalent compounds contain non-metal only, so it is unusual for a metal to form covalent bond. Tin 4 chloride is covalently bonded. A tin atom has 4 electrons in its outer shell. Complete the cross and dot diagram for the molecule of tin 4 chloride. Show the outer shell electrons only. So because tin has 4 electrons in the outer shell, so it will make single bond with each of the chlorine atoms, sharing 1 pair of electrons between the 2 atoms. And for the non-bonding electron for chlorine, we will have 3 non-bonding pairs for each of the chlorine atom. That means 6 outer shell electrons. Now the chlorine atom has 8 electrons in its outer shell, and for the tin atom, it has also 8 electrons in its outer shell. Tin 2 oxide is ionically bonded. The melting point of tin chloride and tin oxide are shown here in the table, and as we can see, tin oxide has much higher melting point than tin 4 chloride. In terms of structure and bonding, why tin 4 chloride has much lower melting point than tin oxide? So of course, tin 4 chloride is a covalent compound, and covalent compound has weak intermolecular forces between its molecules, but tin oxide is ionic in ionic compound, it has giant ionic structure with a strong forces of attraction between the oppositely charged ions. So much higher energy is needed to break the strong forces in tin oxide than that needed to break the weak forces of tin tetrachloride. Part of the reactivity series is shown. Here we have the most reactive, which is magnesium, then aluminium, tin, and copper. When aluminium foil is added to tin sulfate, reaction doesn't occur even though aluminium is above 10 in the reactivity series. Explain why the reaction doesn't occur. Aluminium appears less reactive than it should be because aluminium has a protective layer or unreactive layer of aluminium oxide on its surface, prevented from reaction. An aqueous tin sulfate contains 10 2+ ions. Two experiments are carried out. Copper is added to aqueous tin sulfate and magnesium is added to aqueous tin sulfate. Write ionic equation for any reaction that occurs in each experiment. If no reaction, just write no reaction. For the first experiment, copper is added to aqueous tin sulfate. We will refer back to the reactivity series given here. Copper is below 10 in the reactivity series, so it is less reactive. Copper cannot react with tin sulfate because copper cannot displace tin from tin sulfate, so we will just write no reaction. Magnesium is added to tin 2 sulfate, so magnesium is more reactive than tin. It can displace tin metal from tin sulfate, so we will write the ionic equation. Magnesium plus tin ions present in tin sulfate will displace tin, so we will have tin metal, and magnesium will turn to be magnesium plus 2 ions. That means we will have an aqueous solution of magnesium sulfate and the tin metal will be displaced. Hydrated tin 2 nitrate has this formula: decomposes when it is heated. State what is meant by the term hydrated. Hydrated substance is a substance that is chemically combined with water. Complete the equation for the decomposition of tin nitrate, the hydrated crystals of tin nitrate. Here we have the equation and we have to complete it by balancing the equation. First, we have to calculate the number of atoms on the reactant side. We have 2 tin, and for nitrogen is multiplied by 2, then another 2, so we have 4 nitrogen. For oxygen, 2 by 3 is 6, and multiply by 2, this will be 12. And here we have 20 oxygen, multiply another 2 in the front of the molecule, so we will have 40 oxygen, so the total oxygen will be 52. And for hydrogen, 20 by 2 is 40, again by 2 it will be 80. So let's balance the left side. We will put 2 in front of 10 to have 2 tens, and 4 in front of nitrogen because we have 4 nitrogen atoms. To get 80 hydrogen, we have to multiply the water by 40. Then let's balance the number of oxygen. 2 plus 8, here 4 by 2 is 8, and another 2 here in oxygen, and 40, the total will be 52, so oxygen is already balanced. And this will be the balance of the decomposition of hydrated tin nitrate. Question 4. This question is about sulfuric acid. Dilute sulfuric acid and sodium hydroxide can be used to prepare the salt sodium sulfate crystals using a method that involves titration. This is the purette containing dilute sulfuric acid. Conical flask has 25 centimeter cube of aqueous sodium hydroxide, which is 0.1 mole per decimeter cube. We use thymolphthalene as indicator for this reaction. State the color change of thymolphthalene at the end point. Thymolphthalene and sodium hydroxide at the beginning of the experiment before adding sulfuric acid, it is blue in color, and when we reach to the neutralization point, it will be colorless. So the color change will be from blue to colorless. Suggest why universal indicator is not used for this titration, because universal indicator gives too many color changes, so it will be difficult to see the color change at the end point. 25 centimeter cube of sodium hydroxide, concentration 0.1 mole per decimeter cube, is neutralized by 20 centimeter cube sulfuric acid. Here we have the equation. First, we will calculate the number of moles of sodium hydroxide. It is an aqueous solution, so the number of moles equal to concentration times volume, 25 centimeter cube. First, convert it to decimeter cube by dividing by 1000, then multiplied by the concentration, which is 0.1. So the number of moles of sodium hydroxide will be 0.0025. And because the ratio is 2 to 1, so the number of moles of sulfuric acid is half the number of moles of sodium hydroxide. So to get the number of moles of sulfuric acid, we'll just divide by 2. Here is the number of moles of sulfuric acid. Then to calculate the concentration, we have the volume of sulfuric acid, which is 20 centimeter cube. The number of moles of sulfuric acid equal to concentration times volume. And don't forget to convert the 20 centimeter into decimeter cube by dividing by 1000. So the concentration of sulfuric acid will be 0.0625 mole per decimeter cube. A student is provided with an aqueous solution of sodium sulfate. After the titration, the solution in the flask is sodium sulfate solution. Describe how to prepare pure sample of sodium sulfate crystals from this solution. First, we will have to heat the solution till the crystallization point, then allow to cool. By cooling, the crystals will start to form. So we will filter the crystals and dry between two filter papers. Potassium hydrogen sulfate, this is the formula of potassium hydrogen sulfate, can be prepared by reaction between potassium hydroxide and dilute sulfuric acid, and water is the only other product. So when potassium hydroxide reacts with sulfuric acid, only produce potassium hydrogen sulfate and water. Here is potassium hydroxide formula plus sulfuric acid gives potassium hydrogen sulfate and water. And as we can see, the equation is already balanced. Potassium hydrogen sulfate dissolve in water to form solution X. Solution X contain potassium ions, protons, and sulfate ions. Name the type of solutions that contain hydrogen ions. Hydrogen ions or proton is what makes the solution acidic, so the type of solution is acidic solution. State the observation when the following tests are done. First, a flame test is carried in solid X. Solid X contain potassium ions, which gives lilac color flame, so the result here will be lilac flame. Second, when solid copper carbonate is added to X. So let's write the equation. Copper carbonate is added to solution X, and solution X contain protons and sulfate ions, so it is sulfuric acid. The product here will be first copper sulfate, carbon dioxide gas, and water. So the observation will be first, fizzing due to the formation of carbon dioxide gas. Second, the solution turns blue due to the formation of aqueous copper sulfate, which is blue in color. And the third observation will be the solid, the green solid, copper carbonate, will dissolve and disappear. The last one, aqueous barium nitrate acidified with dilute nitric acid is added to solution X. Barium nitrate is used to test for sulfate ion, and solution contains sulfate ion. That's why a white precipitate is formed. This is the observation, and the white precipitate is barium sulfate. Here we have 0.325 grams of zinc is added to dilute sulfuric acid, and the sulfuric acid contains 0.01 moles. This is the equation for the reaction. Determine whether zinc or sulfuric acid is the limiting reagent. First, we will see the ratio from the equation is 1 to 1. So the number of moles of sulfuric acid needed to neutralize zinc should be equal. We have the number of moles of sulfuric acid, so let's calculate the number of moles of zinc. Here we have the mass, divide the AR of zinc, which is 65. So this is the number of moles of zinc, 0.005, and the number of moles of sulfuric acid is 0.1. The ratio 0.01, and the ratio should be 1 to 1. As we can see, the amount of, or the number of moles of sulfuric acid is much greater than zinc, so sulfuric acid is in excess, and zinc is the limiting reagent because when the amount of zinc or the number of moles of zinc used up, the reaction will stop. That means zinc will limit the continuation of the reaction. So zinc is the limiting reagent because it is present in amount which is smaller than the ratio. That's why it is the limiting reagent. In another experiment, 48 centimeter cube of hydrogen gas is produced from the reaction of zinc with sulfuric acid. And here we want to calculate the number of molecules of hydrogen in 48 centimeter cube of hydrogen gas. It is already given the Avogadro's constant. So first we will calculate the number of moles of hydrogen in 48 centimeter cube. The number of moles of a gas equal to the volume divide 24, and don't forget to convert the volume into decimeter cube by dividing by 1000. So it will be 48 divide 1000 divide 24. Number of moles of hydrogen gas will be 0.002. The Avogadro's constant is the number of molecules present in 1 mole. So here we have 1 mole of hydrogen contains this number of molecules, and the amount that we have 0.02, we want to know how many molecules present in 0.002 moles. So we will make a cross multiplication, just multiplying the number of moles by Avogadro's constant. It will be 1.2 times 10 to the power of 21. Remember that you have to give the answer in standard form. This question is about the rate of reaction in equilibrium. The student investigate the rate of decomposition of aqueous hydrogen peroxide using manganese 4 oxide as a catalyst. The equation for the reaction is given. Hydrogen peroxide decomposed to form water and oxygen in the presence of manganese 4 oxide as a catalyst. As we can see, the hydrogen peroxide in a conical flask on a balance to record the mass, and the manganese oxide here in a container that will be added. We have a loose fitting cotton wool on the top of the flask. The student add the catalyst to the hydrogen peroxide, replace the container on a balance, and start the stopwatch. Record the mass at regular time intervals. Here's the table for the mass, the starting mass at 0 time before adding the catalyst, 50.64, and then as we can see, the mass decreases by time until it reaches constant value here at 210 seconds. Suggest why the mass decrease at time increase. As we can see here, oxygen gas is produced and the flask is not closed. We just have a loose cotton wool on the top of the flask, so oxygen gas escapes from the flask, and that's why the mass decrease. So oxygen gas escapes from the flask, causing decrease in mass. After a certain time, the reaction stops. Why the reaction stops? Of course, because hydrogen peroxide is used up. Suggest why it is not possible to use the result in table 5.1 to determine the exact time when the reaction stops. Let's refer back to the table. As we can see here, the last values are repeated values. So the first one at 210 seconds, and the second one is at 240 seconds. So we have a large time interval between each reading. That's why it is difficult to determine the exact time in which the mass becomes constant. The reason that the time interval between the readings is too long. That means the 30 seconds interval is too long, so the reaction may stop in this interval. We cannot determine exactly at which second the reaction stops. The graph shows the mass decrease against time. As we can see, decrease in mass by time. The experiment is repeated at higher temperature and all other conditions remain the same. Explain in terms of collision theory why the rate of reaction is higher at higher temperature. We know that increase in temperature increase the rate of reaction, and that's because increasing temperature increase the kinetic energy of the particles, so the particle will move faster, and hence we have more frequent collisions, of course will increase the rate of reaction. And increasing temperature will increase the number of particles that have energy equal to or more than the activation energy, so that will increase the rate of reaction. On the figure, sketch the line expected when the experiment is repeated at higher temperature. Of course, by repeating the experiment higher temperature, we will have a higher rate. That means a steeper curve. It will start at the same mass, but going down it will be steeper. Closer to the y-axis means it has higher rate and finishes at the same mass, but in shorter time. Manganese 4 oxide is a catalyst for this reaction. Explain the meaning of 4 in the manganese 4 oxide. 4 is the oxidation number of manganese, which is +4. State how the mass of the catalyst has changed, if at all, at the end of the experiment. Of course, a catalyst is a substance that increases rate without being chemically changed at the end, so the mass of the catalyst will be the same. Here we have to write no change in the mass of the catalyst. Nitrogen monoxide gas and oxygen react to produce nitrogen dioxide at room temperature. Here we have the equation at equilibrium, and the forward reaction is exothermic. Nitrogen monoxide and oxygen are passed in a beaker as shown in the figure 5.3. Explain why this method in the figure not allow the reaction to reach equilibrium. As we can see, the beaker is open, so the gases will never reach equilibrium. The reaction will never reach equilibrium because equilibrium needs a closed system. So a closed system is not used. The reaction will not allow to reach equilibrium. The apparatus is changed and the equilibrium is reached. The temperature of the equilibrium system is then increased and the position of equilibrium shifts to left. Explain why the position of equilibrium shifts to left. By increasing the temperature, the forward reaction is exothermic, so the equilibrium will shift to left because the left side is endothermic, or we can say that the forward reaction is exothermic. So the position of equilibrium shifts to left because the forward reaction is exothermic. The pressure of the equilibrium system is then increased. State the direction, if any, in which the position of equilibrium shifts, and you have to explain your answer. If we increase the pressure, let's refer back to the number of moles on each side. Here on the left side we have 3 moles, and on the right side we have only 2 moles. So by increasing the pressure, the equilibrium will shift forward toward the right side because the right side has less number of moles. So here we will write the direction in which the equilibrium will shift. It is the forward or to right. Explanation: it has less number of moles or less number of molecules. Question 6. This question is about hydrocarbons. State the meaning of the term hydrocarbons. Hydrocarbons are compounds that contain carbon and hydrogen only. Propene, C3H6, can be made from long-chain alkane such as dodecane, which contain 12 carbons. Deduce the molecular formula of dodecane. Because it is alkane, so number of carbons is 12 and number of hydrogen is 12 times 2 plus 2. This is from the general formula of alkane, because alkane general formula is CnH2n plus 2. So the number of hydrogen will be 26. Name the type of reaction occurs when long-chain alkane are converted into shorter chain alkane. The reaction is cracking, where the long-chain alkane is broken down into smaller alkenes. Propene is unsaturated hydrocarbon. Propene react with bromine. State the meaning of the term unsaturated. Unsaturated means it contains carbon-carbon double bond. Write the molecular formula of the product formed when propene react with bromine. Here we will write the equation. This is the formula of bromine react with bromine. It is addition reaction. That means the product will be only one product, C3H6Br2. This is the formula of the product formed when propene react with bromine. A styrene is a molecule represented in the figure. The molecular formula of styrene is C8H8. Determine the empirical formula of styrene. Empirical formula is the most simple ratio of the molecular formula, so we will simplify it by dividing by 8. The empirical formula will be CH. Styrene can be polymerized into polystyrene. State the type of polymerization that occur when styrene is converted to polystyrene, because styrene has a double bond, it's alkene, so the type of polymerization would be addition polymerization. Draw the structure of only one repeat unit of polystyrene, include all the atoms and all the bonds. C6H5 group should be represented as it is. We will not display this part. We will not draw it as a displayed formula. We will just draw it as C6H5. So to make the one repeat unit of the polymer, we will remove the double bond and add two open ends. This will be the polymer formed. As we can see, the same structure, just remove the double bond and draw two open ends. The open end represent the continuation of the polymer. Now here we come to the end of our exam. Comment down below if you have any questions. Like the video and subscribe to the channel to receive all the updates. Thank you for watching. Wish you all best of luck.